Hello. We're going to be looking at solving quadratic inequalities graphically, but we're going to be focusing on interval notation. So when you're looking at these quadratic inequalities, it's very helpful to have the graph, because from the graph you can actually tell where the function's positive and where it's negative. So we're looking for where the y value is positive and negative. So our first question is going to be to solve the inequality x squared plus 5x plus 6 is less than or equal to 0. So we only want those places where that function is below the x-axis, where it's less than or equal to 0. And we're going to list our answer using interval notation. So first of all, we want to get a graph of the equation. It's a parabola. In front of the x squared is positive, so it opens up. And here is a good representation of the graph. So the graph opens upward. You can see here from -3 to -2, it sort of dips below, and left of -3, it's above the x-axis, and to the right of -2, it's above the x-axis. So we already sort of have the answer to our question here. The first thing you would want to do if you're doing this algebraically is find where it's equal to 0, and that's what we're going to be doing here as well, because where the graph is equal to 0, that's the only place where it could change from plus to minus or minus to plus. You can see graphically -3 and -2 would be the places that the graph is equal to 0, so the graph is equal to 0 just at -3 and -2, and that's it. But you could also factor this out. So if you're doing this algebraically, you would factor this into x plus 3 and x plus 2 and get -2 and -3. That would be where they are equal to 0. So those are the intervals we want to check around. So I'm dividing this graph into 3 intervals. One which is -∞ to -3, those are my x values to here. One which is -3 to -2, and one which is -2 to infinity. So we look and we see we want this to be less than or equal to 0. So we want to find where it's less than 0, and right here between -3 and -2, that's the only place where the function is below the x-axis. So this is the interval we're going to choose, -3 to -2, because that function's negative. Over here and here on the ends it's positive. We also want to choose where it's equal to 0, because we have less than or equal to 0. So we're going to use the -3 and -2. That's exactly where it's equal to 0. And since we have that, we have brackets for interval notation. So this would be our answer. X is going from -3 to -2, and we do include those endpoints, so we put square brackets around there. So the square brackets essentially mean that we have an equal sign too, so we take those equal points. Alright, let's look at another example here. So in this case, we want to solve the inequality x squared minus 3x minus 4 is just strictly greater than 0. Even though we don't want to find where it's equal to 0, that's what we should do first. So find where it's equal to 0. So I factored this one out, and it turns out x minus 4 and x plus 1 would be where it's equal to 0. So if I found the zeros there, I would have 1 at -1 and 1 at +4. So you can see that my intervals would look like this down here. I'd have -∞ to -1, -1 to 4, and 4 to infinity. Now we want to see where this function is greater than 0 in this case. We want to see where it's above the axis. We want to see where it's greater than 0 or above the axis. And you can see that from here to here, the left part, and here to here, that's going to be where the function's positive. I've noted that down here. So we want to include this interval. We want to include this interval, but not the middle one, because here this one's below the x-axis, that's less than. So we want to include both of these, and the connector we use is the union symbol. So we use this union symbol to say we want this one or this one. We want to choose those two. If we wanted to choose what's in common, we would use the AND or the intersection symbol, but we want to choose this or this. So both those can be included. We don't want to choose the endpoints this time because there's no equal, so our answer is going to be x goes from -∞ to -1, and x goes from 4 to infinity. And we have parenthetical brackets or parentheses because, again, we don't include, this is just strictly greater than, we don't have an equal sign here. Okay, let's look at one more example. Now we're going to be looking at the inequality where negative x squared plus 3x plus 4 is less than or equal to 0. Now, depending on what you know about parabolas, this one can be easy because you know this is negative in front of the x squared, so you know it opens downward, and if you try to factor this one, it doesn't factor. So what that means is it doesn't cross the axis. It doesn't cross the axis. So if this opens downward and it doesn't cross the axis, what that means is the whole thing is below the x-axis here. So here's the x-axis. The whole graph is below that. We want to find where it's less than or equal to 0. So that would be the whole thing. So notice, if we tried to factor this out, we wouldn't find any zeros. So there's only going to be one interval, and that's the whole thing, negative infinity to infinity. So we're going to be looking at that whole interval. Since this graph is below the x-axis, it's negative, and we want where it's less than or equal to 0, so we want everything in this graph. So every x value is going to work. Every x value I plug in will be below that axis. Okay, so since the entire graph satisfies the requirement, the answer to this problem is going to be all real numbers, or in interval notation, that would be negative infinity to infinity. Notice when you have infinity, you always use a parenthesis bracket, even though I have a less than or equal to here, because you can never get to infinity or negative infinity. It just doesn't happen. Alright, well, I hope this has helped with interval notation and using graphs to help us solve these quadratic inequalities. Thank you.